Okay, so this learning target 10.1 was to use combinations and permutations to determine the number of possible outcomes. Okay, so far we've only been doing permutations. Okay, how many ways could you arrange 3 people in a certain order? How many ways could you vote a president, vice president, secretary from a group of 11 people? Okay, we're putting things in a certain order, a certain arrangement of something. Okay, that's permutation. We haven't done combinations yet, so that's what we're going to teach now. It's still part of this learning target 10.1 because there's different. It matters if the order matters. That's different than if the order does not matter. Okay. So combinations is what we're going to do now. The number of ways you can select a group of objects where order is not important. Okay? And you might be thinking, well, okay, well, how is this going to be different? All right, let me give you an example. Okay? If we have 12 people in like your homework problem, in the Spanish club or whatever it was, and you need to vote a president, vice president, secretary. Okay? There were 12 people in the Spanish club. You need to vote a president, vice president, secretary. How many ways could you do that? Well, what would the math be? 12 times 11 times 10, right? Or 12 NPR 3, okay? Because you're putting them in a certain order. It matters, okay? Now, what if we said, all right, there's 12 people in the Spanish club. We need to choose a group of 3 people to attend this seminar. Does it matter if I choose Colin, Paul, Nick, or Nick, Paul, Colin in that order? No, it's the same group of 3 people, okay? Now, because those 3 doesn't matter the order that I picked them, there will be less combinations of people that could possibly be selected to attend that seminar. Because order doesn't matter. Colin, Paul, Nick is the same as Nick, Paul, Colin. But going back, if I said president, vice president, secretary, now is that different if I go Colin, Paul, Nick versus Nick, Paul, Colin? Absolutely. Okay, because different people are presidents, different people are secretaries. Yeah, Paul's the same in the middle there. Okay, but it's different. Okay? So when order does not matter, you're doing a combination. Okay? That's why actually, you know your combinations for your P-lockers? They really shouldn't be called that.
Because order does matter.
But order matters that you do the...
So it's a locker.
It's a permutation.
Locker permutation.
Alright?
I'll start saying that. I'll try.
You have to put those numbers in the right order to open the lock. Alright? It's not a combination of numbers. Alright? The order matters that you do that. Otherwise it won't open. Okay? So anyway, just a little pet peeve. Alright? Combinations. Where else are combinations? Powerball. Powerball is combinations. You don't actually need to pick the correct 5 white balls in the exact order that they come out of the machine. That would make it even more impossible to actually get those numbers right and win the lottery. You just need the right group of numbers. Okay? If the numbers come out 1, 2, 3, 4, 5 and your ticket says 5, 4, 3, 2, 1, you still win. Okay? You have the right group of numbers. Okay? So combinations is when the order is not important. Okay? Combination is when the order is definitely not important at all. Okay? We'll do a lot with a 5-card deck of cards dealt to you. Okay? If you're playing poker or you're playing any, or euchre, you get 5 cards in euchre, or I don't know if somebody play pitch or anything like that. Okay? When you go fish. Alright? When you are dealt cards, okay, if you pick all those cards up and look at them in your hand, does it matter the order that the cards came to you? No. All those cards are part of your hand. Okay, so that again, we'll be working with combinations. Okay, so combinations, order, not important. Permutations, like we did before this, the order is important. Okay? Alright, so, you know how the permutations we had NPR? Okay, now we're going to have NCR. Okay? And you will actually want to use this one a lot more than probably the NPR. Because with the NPR, you can just do the, like with the Spanish thing, 12 times 11 times 10, get your answer. You could have also done 12P3, right? Sometimes it's faster to just do 12 times 11 times 10. Here, there's no real fast way. All right, you're actually going to want to use NCR when it calls for combinations. Okay? First of all, NCR, here's the math behind it. N factorial divided by N minus R factorial times R factorial. Not necessary. I'm not going to make you use this. Okay? You can just enter the NCR on your calculator. Okay? And it represents the number of ways R objects can be selected from a group of N objects, and order does not matter. Okay? NCR is the math you will use to determine the number of ways that R objects can be selected from a group of N objects, and order does not matter. So going back to the Spanish club problem, okay? If there were 12 people in the Spanish club and we need to choose 3 of them to attend some conference, you do 12 NCR 3, because there were 12 total people to choose from, and you just need to choose 3 of them to attend this seminar, and the order you select the 3 people, it does not matter, okay? You're just choosing 3 people to attend this conference. Okay, so you do 12 NCR 3. Alright? Powerball jackpot, just with the white balls, okay? There's 59 white balls to choose from. You need to choose 5 of them, okay? How many different combinations are there?
There's 59.
There's 59 total to choose from. You've got to choose 5, so what would you have to do mathematically to see how many different combinations you could get? 59 NCR 5. That'll tell you how many total combinations there are to choose from when you go to pick which numbers you want. Okay? A lot. Okay? Definitely different. That number's going to be smaller for sure than if it were in PR. So when do you use NCR?
When it doesn't matter.
When the order does not matter. When do you use NPR? When it does. Here are some key words. Choose. Choose starts with a C. You're choosing a group. Okay? You're choosing a group of things. Okay? When you're putting something in a certain order. When you're putting something in a certain position. Okay? P. You're putting things in a certain place or a position. Okay? NPR. Okay? When you're just choosing a group of something where order does not matter, you use NCR. Alright? Time's like 9. Alright, I want to talk about a deck of cards. This is going to be something you're going to want to know. Okay? So if you don't know about cards, you want to write this down. Okay? There are 52 cards in the deck. No jokers, okay? 52 cards in the deck, we're not putting jokers in there. Alright? There are 13 of each suit. When I say suit, you guys know what I'm talking about. Clubs, hearts, spades, diamonds. Okay? Clubs, hearts, spades, diamonds. There's 13 clubs, 13 spades, 13 hearts. If you know all this stuff, don't write it down. But if you don't know it, you better write it down because you're going to need to know it in order to do some of the problems. Okay? 13 of each suit. There are 12 face cards. in the deck. Face cards are jacks, queens, and kings. So there's 3 face cards in each suit. And since there's 4 suits, alright, that makes 12 total face cards. Jack, queen, king of clubs, jack, queen, king of spades, and so on. Okay, 13 of each suit, 4 suits. Let's see, what else? Obviously then, I guess if you don't know, there are 4 aces, there are 4 2s, there are 4 3s, there are 4 4s, and so on. There's 4 of every kind of card, alright, in the deck. That's really, I can't think of anything else that you need to know. Okay. Oh, I guess half of the cards are black, half of them are red. Okay, there are 26 red cards, 26 black cards. The spades and clubs, okay, are the black, and the diamonds and the hearts are red. Okay? Any questions on the types of cards? Okay? How many 5-card hands could you be dealt? So I'm the dealer. I'm going to give you a 5-card hand. We're playing 5-card stud, or playing poker or something. Okay, I'm going to give you 5 cards. How many different 5-card hands? You don't need to do the math. You can just tell me what math to do. Okay? We can get the numbers here in a second, but I just want to know, do you know what to do? 52, NCR, 5? Does that make sense? Why is it 52? That's how many total cards I have in my hand. I'm the dealer, okay? I got 52 cards in my hand. You're getting how many of them? 5. Does the order matter that you get those 5 cards? Not at all, okay? So the answer to this would be 52 NCR 5. Now, if somebody has taken the time to do that, has anybody done that yet? Okay? Yeah, I know. Sometimes people don't listen to me, though, you know.
Like Zach, he's back.
Let's beat him up after class.
Yeah, for being bad in class.
Okay? There are over 2.5 million different hands you could be dealt. Okay? There are over 2.5 million different 5-card hands that you could be dealt. Alright? So the chances of you getting a royal flush are between slim and none. Okay? If anybody knows what that is. Okay? That's like when you get ace, king, queen, jack, 10 of a suit. So you get 5 in a row. So like you have the ace of clubs, the king of clubs, the queen of clubs, the jack of clubs, the 10 of clubs. That is the best poker hand. If you get that in Vegas, you're going to win, depending on your bet, but thousands and thousands and thousands of dollars. Okay?
Are you telling us to go to Vegas?
No, because there are only 4 royal flushes possible to be dealt. So the probability of you getting a royal flush dealt to you would be 4 out of 2,598,960.
So there's
So
a chance.
So there's a chance.
There's a chance.
Alright?
So if I bet that many times, I'll get 4 royal flushes?
Well, theoretically, you should. Yes.
I will. I will.
Theoretically.
No, I will.
Not guaranteed to happen. Not guaranteed. Okay?
Bet like a penny each time.
See where my time is.
Field trip, Vegas.
Nope. Pause.